And welcome back all. Now we're going to take it up another notch in complexity and we're going to talk about timers. And it goes without saying that in process control you want some things to happen after a certain delay, some things to start or shut down. You don't want to sound an alarm the second an errant condition occurs. You want to see if it smooths itself out after 3 or 4 seconds. Sometimes you want a warm-up cycle in a process for 15 to 30 minutes. There's lots of different reasons, lots of different things you're going to need timers for. So they're going to be a very big part of most of your programs. So we're going to look at a few of the common timers. And as usual, the first type of timer we're going to look at is the one that will do almost everything you need. There are a couple of other options for timers, and we're going to look at those as well. But the first one we're going to look at is the TON, which means timer on. And this is a little bit more complicated than most people would think a timer needs to be, but it's a good thing because the complexity's there, but that doesn't mean you always have to use it. So this is how it works. When we look at rung 0 in our program, of course our condition is our light switch 1, and I have a light switch 2 down here, so we're going to call this light switch 1 this time. So what happens is first it looks for me to have that switch in the closed or on position. So once I flip that switch, now we energize this timer. And we've got an address of T4:0, which correlates to our data table. And when we open the data table, we see we've got an EN bit, a TT bit, a DN bit, a base, a preset, an accumulator, a symbol, and a description. So there's a lot going on in that timer data file, and we're going to see what all that's about. The first thing is our time base, and when we look at that, we have some options of how we want to set our time. We can count seconds, we can count hundredths of a second, or we can count milliseconds. And unless you're really just using a time critical application where milliseconds really count, most of the time it's just as practical to use seconds. So I've got here a preset of 5 of whatever this time base is. So if I have this set at milliseconds, then this is 5 milliseconds. But right now I have this set at 5 seconds. So this is a 5-second timer. And the accumulator is going to start accumulating time. In other words, it's going to start counting up once this condition is met and becomes true. Now on the far side of this timer, and these are all part of the block, you have an EN and you have a DN. And I'm not sure why it shows those two and not TT, but there should also be a TT down under here, but it just wasn't created as part of the block. It's just one of those things. But we're going to talk about all three, even if it's not part of the symbol. So here is how this timer works, and it's got a lot going on. Once we close our light switch, we energize our timer, and once it becomes energized, that's what this EN bit right here is. And as long as this light switch remains closed, this timer will always be energized. It doesn't matter if it's timed out, if it just started counting. If everything to the left of the timer is true, then the timer is considered energized. So when we come down to rung 2, we're evaluating T4:0/EN, and we're looking sure enough to see if that energized bit is energized. Well, assuming it is, our light bulb 1, 2 is going to illuminate. So basically, anytime light switch 1 is closed, light bulb 1, 2 will be energized. Okay, that's one of our 3 bits on this timer. The second bit is DN, and DN means down, short for countdown. So what happens, back to square one, our switch is open and we close our switch. And immediately our timer starts counting. 1, 2, 3, 4. Once it gets to 5, it's going to stop counting and this accumulator is going to stay at 5. Once it hits 5, it has counted down, so this DN bit is going to energize, which means when we come to rung 1, we're evaluating T4:0/DN. That's our down bit for timer 4-0. And once this time's down, this bit is going to energize and our light bulb 1-1 will come on. This will stay down, this will stay energized, and this accumulator value will stay at 5 until one of 2 things happens. One, until this condition becomes false, in other words, we turn our light switch off, or there is actually a reset, RES command, that we can use that instruction as an output on this timer, and it will reset the accumulator and start over again. We're not really going to talk too much more about the reset, but that works on timers, that works on counters, and that's how the down bit works. So once it times out, it will stay timed out, and that down bit will remain energized as long as everything to the left remains true. And obviously, the energized bit will stay energized as well. Now we have this third bit, this TT bit, and TT somehow means timing. So back to square one, we flip our switch from the off to the on position, making this instruction true. Once we do, we already know what happens to our timer. It energizes, it starts counting. Well, once it starts counting, that's what timing means. So this TT bit is going to go ahead and energize, and our light bulb 1-3 is going to come on. However, once our accumulator gets up to 5, which is our preset value, now it's no longer timing. It has actually timed out. So now our TT bit will de-energize and our light bulb will go off, even though our energize and down bits remain on. So looking at all 3 of those together, when we flip the switch and we go from off position to on position, immediately our TT bit energizes and our energized bit energize. 5 seconds later, our TT bit de-energizes and our down bit energizes. Our energized bit remains energized because our timer's been energized all this time, so it doesn't de-energize. What we have then is the light bulb 1-2, which is tied to our energized bit. It's like it's tied directly to our light switch. When our light switch is on, light bulb 1-2 is on. When light switch 1 is off, naturally, light bulb 1-2 is off. Our light bulb 1-1 comes on a 5-second delay. So once we flip our switch, light bulb 1-1 stays off for 5 seconds, then it comes on and stays on until we flip the switch off. Our light bulb 1-3, when we flip the switch, it comes on, but it only stays on for 5 seconds and then it shuts off. So that is how TON works, and those are the 3 control bits that work with TON. Now once you've learned TON, timer on, timer off is very easy to understand. Remember, timer 1 looks for the conditions on the left to be true, as do almost every other output in RS Logix 500. Timer off, however, is one of those freaky little exceptions. When this is true, this timer is de-energized. But once this becomes false, in other words, once we turn off our light switch, then the timer starts to count, and it has an EN and a DN and a TT bit. It's otherwise exactly like timer 1, only it works when the conditions are false instead of when the conditions are true. So if we have two sets of lights, set 1 consisting of lights 1, 2, and 3, and set 2 consisting of lights 1, 2, and 3, these three lights will come on when we turn light switch 1 on. These three lights, on the other hand, will come on when we turn light switch 2 off. So that's that. There is one other timer, and I didn't draw that out separately because it is basically exactly the same as TON, timer on, only this is a retentive timer on. It works exactly the same with one exception. When we're looking at our TON, when we turn our light switch on, it starts counting, and let's say it gets up to 3 seconds and we flip the light switch back off. Our accumulator resets to 0. Then when we turn our light switch back on, it begins to count again. And if we never leave our light switch on for 5 seconds, our timer will never time out. But anytime we open our light switch, anytime we turn it off, the timer will automatically reset without the use of a separate reset command. Retentive timer requires a reset. In order to reset the accumulator, you have to use a reset command. So if I turn my light switch on and I leave it on for 1 second and then I turn it off, this RTO accumulator will count up to 1 second and it will stay there. Even though my light switch is now off and my timer is de-energized, the accumulator will not reset. So when I turn it on again for another 2 seconds and then turn it off, now my accumulator adds those 2 seconds to the previous second that it was on. Now my timer is up to 3, which means once I turn my light switch on again in 2 seconds, this timer is going to time out, and it will retain that time until I use a reset command on T40. And once I energize that, then it'll reset the accumulator. But aside from retaining the accumulator value, RTO works exactly the same as TON. So your homework after this lesson is to study the timer a little bit and make sure you understand the operation of the DN bit, the EN bit, and the TT bit. The countdown, the timer energized, and the timer timing bits. The accumulator and the accumulator value and the preset value can also be changed from within the program, and they can be referenced from within the program. So that makes these timers very, very flexible, very, very useful.